Okay, welcome everyone to the presentation of the Artificial Intelligence Bachelor curriculum. I'm recording this presentation because the university might use it at a later point, but once I'm done with my presentation, I will stop the recording and then we can make a Q&A session and try to answer all your questions. So artificial intelligence is a very broad and interdisciplinary discipline. And in the beginning of my presentation, I will discuss the definition, also the impact on society and economy, and some modern interesting applications. And then in the second part of the talk, we will discuss the study programs and general information. I will tell you about our distance learning philosophy, and we will have a look at the study plan of the bachelor curriculum. Artificial intelligence is not so easy to define, but there's a kind of general consensus, namely that it refers to the ability of machines to perform cognitive tasks commonly associated with human intelligence, so including perception, learning, reasoning, planning, speech and language, and also taking actions. And in many tasks, computers have meanwhile reached superhuman performance. An old thought experiment dates back to Alan Turing, one of the founding fathers of computer science. And in 1950, he came up with the concept of a Turing test, where a computer needs to pretend to be a human. And if another human cannot distinguish between a human and a computer, because both behave similarly, maybe sending text messages or whatever, then the computer has passed the Turing test and has sufficiently demonstrated intelligence or consciousness. And in many respects, this Turing test can be passed. Of course, we cannot yet build robots that perfectly look like humans, but when you hear a piece of music or see a painting digitally, you will not be able anymore to tell whether this came from a human or it was computer generated. So for instance, these paintings here, all of them are computer generated and even could convince a jury at an art exhibition. AI is connected to many other disciplines. It's itself a subdiscipline of computer science. It heavily relies on mathematics. It's connected to sociology, philosophy, and psychology because of the theory of mind and the whole concept of intelligence. Then the whole field of bioinformatics is somehow closely related. And on the other hand, artificial intelligence itself is composed of many subdisciplines, which we try to cover in our curriculum. There's the whole field of logic, knowledge representation, perception, natural language processing, planning and robotics. And where we have a focus here in Linz would be machine learning and neural networks. So artificial intelligence is this broad interdisciplinary discipline, which dates back already to the 1950s when Arthur Samuel had two PCs play checkers against each other. Perceptron was the first artificial neuron. Joseph Weissenbaum's ELIZA was a kind of rudimentary chatbot. And as I just told you, we have subdisciplines, and a very powerful subdiscipline is machine learning. It came up in the 1980s and was able to perform optical character recognition, the spam filters, genomics, and also the first Google search. They all are machine learning techniques. And then 10 years ago, about a kind of revolution started, because all these modern developments of artificial intelligence, which you hear so often in the news almost every day, all the modern image, text, voice, music, video recognition and processing, autonomous driving, board games like Go or strategy games. This is all in the deep learning breakthrough. So all deep neural networks that perform these tasks. And the deep learning revolution bases on theoretical concepts of the 70s, 80s, and 90s. But it was possible only around 2010 to really kick off, because at that moment, we had sufficiently fast computers and sufficiently large and nicely labeled data sets. So it's fast computing power and large data sets that made the deep learning revolution possible. And in some sense, you can compare it to the example that electricity. So you want to have electricity in your power socket, but where does it come from? It needs some resource: oil, gas, coal, wind, solar, or uranium. But it needs to come from somewhere. And similarly, modern artificial intelligence, when you think about modern AI achievements, what is the resource for it? And the resource is data, 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 and fast computers. AI is almost and probably will be omnipresent and pervades commercial applications and is fundamentally changing how businesses operate virtually across all sectors in industry. So more or less, you now have to start asking, where will AI not play a role? So in information technology, as I said already earlier, speech, image recognition, translation, you have a Siri, Google Translate, Alexa at home. This is all modern AI technology. In manufacturing and supply chains, artificial intelligence can help to optimize the production and delivery processes. In medicine and healthcare, it allows to assist with diagnosis and evaluations. In drug design, modern artificial intelligence can help to predict toxicity or other behavior of molecules just from the genomic sequence. In education, news, publishing, marketing, and other services, recommender systems help to make the best possible next recommendation. So you have that every time on Amazon or YouTube or wherever. And also a very important topic, self-driving cars and trucks. Modern approaches are all based on deep learning techniques. A standard hard coding, this has all failed. So since 10 years or so, nobody tries anymore to program all the possible conditions on a road. No, we do it as we humans do. We have a neural network, and by driving and gathering lots of data, the cars learn to drive. It's really learning and not being programmed. The impact on economy is believed to be very big. This is a bit outdated now, 2016, but the prediction is that for the next 1 or 2 decades, there's a huge difference on whether or not a country can adopt AI into its economy and society or not. So countries like Austria, Germany, or France, they have a baseline GDP growth per year of about 1.5% if they fail to adopt artificial intelligence. But if we do not lose track and keep to be on the forefront of modern developments, then the GDP growth rate can be much larger. So the wealth of nations is predicted to somewhat depend on whether or not we can adopt artificial intelligence into our industry and economy. Deep neural networks are one of the main things in artificial intelligence because they are at the heart of machine learning, and they try to mimic the human brain, where you have lots of artificial neurons that are connected by weights, and by feeding them data, they make better and better predictions for future tasks. And building such networks, so finding out the architecture, the training techniques, the normalizations, this is all an art, and we need students that learn that, because this is far from trivial. This is not easy, but the cool thing is that once you have trained a neural network, they are super fast and super powerful, and you can put them on a mobile phone and, for instance, have recognition of objects in real time. So I quickly show you a part of a video from an app which is for blind people or visually impaired people. And the app was trained on billions of images. It can recognize 5,000 objects in practically real time. So training that neural network was a huge amount of time and work and money, but then it's really fast. So let's have a quick look at this video. So, of course, it's not real magic. There is no such thing, but it is close to it, because 10 years ago, such things would have been completely impossible. Another interesting example would be generative adversarial networks, where two networks play against each other, and one gets better in faking stuff and the other one gets better in discriminating. This also dates back to the ideas of Arthur Samuel. And for instance, if you look at these celebrity pictures here, you can ask yourself who is a real person and who isn't. And if you look close enough, you will find some mistakes at some places. And in fact, these are all computer generated pictures. And such networks can be used to be trained to change styles, horses to zebras, winter to summer, and so on. So this is a very powerful technique that allow you to produce or fake things. Another very important topic, which we also cover in our bachelor's curriculum, is the field of reinforcement learning. It's a very general approach where agents learn to behave in an environment and update their policies of taking actions by getting rewards or punishments, negative rewards from the environment. And this is a technique that is closely to probably how we human work. So if a baby learns walking, nobody goes into the brain of the baby and programs it to work, to walk, but it simply walks and falls and walks and falls, and it prevents falling. And this is how you can also train drones to stabilize themselves. You could try to program it from scratch, which is very hard, or you simply feed in a reinforcement learning algorithm, and then you throw it 1,000 times. And after throwing 1,000 times, it will have learned in all possible combinations the best possible way to stabilize itself without falling to the ground. And in a similar manner, you can train board games or strategy games. So chess is a comparatively easy game. It was solved already in 1997 when IBM beat Garry Kasparov with a standard hard-coded position value, hard-coded brute force program. So computers were simply fast enough to beat the best human. Go is a much more complicated game. It has a much higher complexity, and normal computer programs can only reach medium level. So humans are still better than, I would say, classical computer programming. But if you use deep neural nets to value the position on the board and let the nets play against each other, they achieve superhuman performance. And since 2017, no one can beat AlphaGo anymore. And meanwhile, there's AlphaGo Zero. It just starts with the knowledge of the rules. It plays against each other. After 3 days, it reaches a master level. And after 3 weeks, it reaches the level of the best human, and then the sky's the limit. So there's this is a deep reinforcement learning architecture that simply achieves superhuman performance. The final example is AlphaFold. One of the holy grails of biology or structural biology for many decades was, if I give you the genomic sequence of a protein, I just give you the sequence A, C, T, G, and so on. How does the protein look like in real three-dimensional space? And it's very important how it looks like, because can it fit through a channel? Can it dock somewhere? Is it toxic? And so on. And for decades, the best possible structural biologists or computer scientists could only have a 40% accurate prediction. But in the last 5 years, this problem was tackled with deep learning. And now there's an almost 90% accuracy in predicting the structure from the sequence. And this was a breakthrough result last year. So coming to the end of the first part, how far are we away from real science fiction, so from real AI? And there nobody knows. It's unclear whether all we know from artificial intelligence can ever reach so-called artificial general intelligence. It would be a machine with a behavior at least as skillful and flexible as a human. But regarding computer power, it should not be a problem. It's more the problem of whether we find the right architectures. If you look at this logarithmic plot of the best computer in the world versus time, so Second World War until now, and here the peak operations per second, this is a logarithmic plot, then this is the miracle of the 20th century. This is the Moore's law. Computers get exponentially faster. In the logarithmic graph, it's a line, but in fact, it's exponentially. And it's millions of people and trillions of dollars that achieve that. So today you can buy for €1,000 a GPU that has as much computing power as the best multi-million-dollar computer in the early 2000s. And this orange bar up here is the estimated computing power of the human brain. It's somewhere between 10 to the 18 and 10 to the 25. And maybe in 10 more years or so, we will have reached this computing power. So it depends a bit on your worldview, whether you want that to happen or not, and whether you have a dystopic or utopic view. But regarding computing power, the brain is not safe. We will probably reach that. Whether we can reach it regarding, so to say, the software architecture, this is unclear. But this is just for fun. In some sense, we still don't know, as people didn't know 100 years ago, whether we will ever have machines that are as good as we are in all respects. So let's come to the study program. We started our bachelor's and master's degree in artificial intelligence in 2019 simultaneously. So our master's program, which is 4 semesters, the first students already finished in summer. And in the bachelor's program, our first students will finish this summer because they are now in the 6th semester. We do not have any access restrictions, so all you need to study in the AI program is a Matura or some equivalent certificate from a foreign country, so a high school leaving exam, and proficiency in English. So all Austrian Matura will be fine because you have English. If you come from a foreign country, it depends on the English lessons you had. Otherwise, you have to maybe show some kind of English test. But for in Austria, this is an open study. With the Matura, you can start. We were and still are among the first AI programs in Europe that teach modern artificial intelligence. We were, and I think still are, the first dedicated AI program in Austria. I think now there's some master's program, but I don't know whether there's already another bachelor program in AI in Austria. Yeah, as I should have said in the beginning, since this talk is in English, we fully teach in English. All our mandatory courses in the curriculum are in English. We are largely available via distance learning. I will say that in a minute. And we are a technical program. So you should like mathematics, and you should like learn to like programming. It's a technical curriculum, but we have a bit wider scope. So 10 or a bit more credits are devoted to AI and society. So you will learn about the sociological questions and implications of artificial intelligence to our society. Our bachelor's program is a standard Bologna type program. It's designed to be 6 semesters, 30 credits per semester, 180 credits in total. It's a fundamentally disciplinary program, but you will get a core education in computer science and mathematics. So you will learn to program in Python. You will learn calculus and linear algebra on the level of physicists or mechatronics people. And then you have the core AI subjects. We will look at the study plan in 2 slides or so. Yeah, and you should, of course, know that then there exists a master's program. So if after the bachelor's you want to continue, we have a master's program with 4 different tracks and a special focus on deep learning. So now a minute to our distance learning philosophy. Our curriculum is, in one sense, a curriculum as any other here at jku. So you can come physically to the courses. Corona pandemic is over in the sense that we are back to university. All lecture halls are open. So you are very welcome to study the normal way, to go to the lecture halls, to meet your fellow colleagues, to be in the classes, in the exercise groups, and so on. However, if you prefer to do it in a more remote way, maybe you don't live very close to Linz or for some other reasons, you have the choice to use our distance learning offers, which means that all courses offer their contents available, offer the contents online, so lecture notes and slides and so on. Most courses are even live streamed, and if they are not live streamed, then they are recorded, and you can watch the video for at least 2 weeks in Moodle, which is our learning platform. Exercises usually demand presence, but if they really demand presence, then there's always an online group. So then there might be really a certain time, a day of the week and time, where you have to be online in Zoom, but you need not physically come. So virtual presence we do demand, but not necessarily you need to come to jku. Well, when do you really need to come? This is for exams. If exams are, most of exams are online also, but if exams are not online and they need to be written in the lecture hall, then you need to come to jku or to Vienna or Bregenz, because we have 2 distance learning centers in Vienna and Bregenz. So if you live close to either of those 2 cities, that will be very fine for you too. You can simply go to Vienna or Bregenz and write your exams there. So the number of required days of really physical presence at jku, except for the exams, is only about 1 per term. And with the exams, it's maybe 5 or around 5 times that you really need to come. The rest you could do in our distance learning mode. But let me still repeat, we very much welcome, and I think at least half of the students are close, live in Linz and do come. So we are very happy that lecture halls are full and there's direct participation with the teachers. It's just, our curriculum just has the 2 pillars, and it's totally up to you how you want to choose. And you don't even have to tell us and commit. You don't have to say, I'm a physical presence student or I'm a distance learning student. You choose course by course how you want to do it. Okay, yeah, this is the overview of the program. I already said it's 6 semesters, 180 credits taught in English, and yeah, location is in Linz, but we have the optional distance learning and also Vienna and Bregenz. And it's designed to be a full-time curriculum, so it's designed that you study like, I don't know, roughly 40 hours a week, such that you can finish in 6 semesters. Let's maybe finally have a quick look on our ideal study plan. So these are the 6 semesters of the curriculum, and we have subjects. So in AI basics and practical work, you will get an introductory lecture right in the 1st semester, and in hands-on, you will immediately play around with Jupyter notebooks, some machine learning, interesting things. They are prepared such that you can immediately start without any prior knowledge, but we want our students to feel immediately that they are artificial intelligence students, because otherwise the 1st semester is quite tough. You need to learn programming in Python, you need to learn mathematics, you need to learn logic. So you have many basics that you have to fill up anyway. And here you will immediately see interesting AI applications. In AI and society, as I mentioned earlier, you get this a bit broader view about responsible AI and the impact of technology and the impact of AI onto society. In our computer science subjects, yeah, as I said, you will learn programming in Python and algorithms and data structures, which are standard computer science topic. Then we have a big subject here in data science. You will learn about statistics, visual analytics, learning from user-generated data, so from large data sets created by users themselves, and more statistics, natural language processing, which is a very important field in AI, and some digital signal processing. Yeah, then we have the subject on knowledge representation, reasoning, with logics and formal models. It comes to this reasoning and planning topics in AI. And then we have a heavy focus on machine learning and perception. You will learn about the most basic techniques, the supervised techniques, where there are also neural networks taught, unsupervised techniques, machine learning and pattern classification, and reinforcement learning. So here you will cover the machine learning and neural networks part of artificial intelligence. Yes, and as I said already earlier, you need to have an inclination to programming and mathematics. We have a 3-part mathematics course and plus an optimization course. So mathematics in terms of volume here in Linz is on the level of the physicists and mechatronics students. We teach less mathematics than in a full math curriculum, of course, but you will need more mathematics than, for instance, in an informatic studies. Okay, and that I think brings me to the qualification profile and my final slide. Yeah, addition, we talked already a little bit, it's Matura or equivalent, including the English level. We offer a broad and balanced foundational education in math and computer science, and then specialized training in core AI subjects, machine learning, data science, knowledge representation, reasoning, natural language processing. But you will also get a broader view on the ethical implications of AI for society. Our focus is that you learn to systematically solve problems. We try to promote your social competences by teamwork or practical trainings, because we want you to acquire the skills that are relevant for your later careers. And what is the aim of our bachelor's program? It's the aim that every good program should have. It should prepare you to either go on with the subsequent master studies in AI or some related field, but a bachelor program also needs to be able to stand for itself. So our goal is that you are prepared for the immediate entry into the job market if you wish to do so. So we hope that we train you, that you will be able to develop AI solutions in many different sectors of AI, of industry and economy. Yeah, I can jump over the master's program and go to my final slide. So for further information, of course, there is a web page which shows you lots of information about our AI curriculum and the program details. If this link is too long to write down, then you just Google AI JKU and get the first hit. And if anything comes up, there are some email addresses to people you can write to, for instance, to the admission office in case you come from a non-EU country and might have some questions. We also have a AI lab office whom you can email. And in case you don't know at all what to do, you can email me and I will be happy to guide you or help you. With this, I thank you very much for listening and joining in to my presentation. I will now stop the recording and be available for questions. Okay.